So now we are starting with the module 3 magnetic circuit. In this, one of the question you will definitely get based on the dot convention. Okay, so what is basically a dot convention? Like if one current is entering, okay, like suppose this is the inductor, and if we place the dot over here, that what it represent the current is entering into the inductor, right? That means current is entering into the inductor. And suppose if we are having an inductor and dot is placed here, right, at here at the end, that simply represents that current is leaving the inductor. Got it? That represents current is leaving the inductor. If it is on the starting, then that means entering, and if it is on the ending, then that means leaving. Got it? Clear this case? Now if two inductors are connected in series, like suppose this is the case, in this case dot is here, dot is here, that means in both the cases current is entering, right? Or what we can have in this case, that what we can have in this case, if L1 and L2 is there but dot are on the ending side. Ending side means ending side means ending side means it is leaving, right? Ending side means it is leaving. So what does it mean? That both are connected in series aiding connection. Series aiding connection means for the first case current is entering in both the cases, in the second case current is leaving in both the cases, right? And there must be a self inductance. Self inductance is denoted by L1 for the inductor, and self inductance for L2 is denoted by L2. But there must be a mutual inductance between these two inductors because they are connected in series, right? So that's why if we want to calculate L equivalent, means total equivalent, then its formula is L1 plus L2 plus 2M. 2M means, that means L1 is for the self inductance, L2 is for the self inductance, and 2M, M is for the mutual inductance. Like if we have studied in the transformer, if you remember it, that if we are having a transformer like this, both are connected like this, so there is a self induction and this inductor is placed nearby to the this, right? So its magnetic field interact with the other inductor or not? So it will have the effect of mutual induction also, right? It will have the effect of mutual inductance also. So in that case we'll have that formula. Now after this, if suppose again two inductors are there, but one dot is at the entering side and one dot is at the leaving side, okay? Here the current is entering and here the current is leaving. That means this one is the case of series opposing connection. Got it? This one is the case of series opposing connection. Again, I'm taking the next case. Opposing means one is entering and another is leaving. Yeah, in this case, for the opposing case, it will have different formula. Or we can have one is leaving and another one is entering. Yes or no? So for the L1 it is leaving, but for L2 it is entering. So for this case, the L equivalent formula is L1 plus L2 minus 2M. Got it? L1, it is all, both are the cases of series opposing. If one current is entering and one is leaving, that means it's series opposing. And if one current is leaving and another is also leaving, or one current is entering or another is also entering, that is known as series aiding connection. And for both the cases the formula is different. Okay, next one is if suppose two inductors are connected in parallel. Okay, that was the case of series. Now the inductor are connected in parallel. This one is L2, this one is L1, and this one is L2. Here the current I is flowing and the mutual inductance between them is M. And in both case it is leaving, right? Both the inductor current is leaving. So in this case, L equivalent formula is L1 L2 minus M square divided by L1 plus L2 minus 2M. Got it? So this is actually known as parallel aiding connection. What is it is known as? Parallel connection. Now the next case, if two inductors are connected in parallel, but if it would be parallel opposing connection. Opposing means here current is entering and here current is leaving, right? L1 L2. So L equivalent is how much? L1 L2 minus M square divided by L1 plus L2 plus 2M. Okay. In the previous case it is minus 2M and in this case it is plus 2M. So this is known as parallel opposing connection. Got it? Now see one more formula you need to write down. K is equal to M divided by root of L1 into L2. Okay, this is known as K is what? K is basically known as coefficient of coupling. Okay, so it would be K12 would be M12 divided by root of L1 into L2. Okay. Now check this question. They said two coils are connected in series. So let's mark two coil connected in series having total inductance. Total inductance means L equivalent is how much? 250 millihenry when connected in series opposing connection. So series opposing connection means L1 plus L2 minus 2M, right? If they are saying that, yeah, series aiding, then L equivalent is this one. If series opposing, then L equivalent is this one. So can we say that L1 plus L2 plus 2M is equal to 250 millihenry, right? And L1 plus L2 minus 2M is equal to 150 millihenry. Yes or no? Now they said if the inductance of coil L1 is 3 times of L2, then find L1, L2, M and K. After solving, you are getting the value of L1, L2 and M. They are asking coefficient of coupling. Coefficient of coupling is denoted by K, and I told you the formula for coefficient of coupling. K is equal to M root L1 L2. See, in this case, what they have said, two coils of coefficient of coupling 0.5 means K value is how much? 0.5. Between them are connected in series means two coils there. That means they are connected in series in the same direction and in the opposite direction. The corresponding values for total inductance 1 means for the series. L equivalent is equal to L1 plus L2 plus 2M is how much? 1.9 Henry, and L equivalent is L1 plus L2 minus 2M is how much? 0.7 Henry. They are asking find the self inductance means L1 value, L2 value and the mutual inductance value, right? So now you know all the values, you just need to substitute in the formula. Correct or not? See in this question, what will get? L1 plus L2 and 2 is equal to how much? 2.5. If I'll add this equation, then it would be 2L1 plus 2L2. Yes or no? Okay. Now from here, can we get the value for L1 plus L2? L1 plus L2 is how much? That is 2.5 divided by 2. Correct or not? Hmm? Yeah, sorry, it's 2.6 divided by 2. So you are getting one equation. So it would be 2.6. If I'll put L1 plus L2 value over here, that is 2.6 divided by 2 means 1.3, right? So L1 plus L2, what we are getting, that is 1.3. So 1.3 plus 2m is equal to 1.9. Can we get the m value from here? And if we got the m value, we can substitute the m value here, right? Similarly, k value we already know. Can we get the L1 L2 value? The combined. And can we write down L1 is equal to 1.3 minus L2? So we can substitute it here. Then we'll have two variable, two equation. Now you can solve it. Yes or no?